Officer and Vice President of International Sales at Linear Technology. Wave, that's it. And we've got Mr. Daniel Quinger, CEO of E-Mobility, Lion E-Mobility, and Managing Director of Lion Smart. Mr. Daniel Quinger. And we have Miss Joy Weiss, President of Dust Networks, the enabler of Smart Mesh IP. Now together, for the next 20 minutes, we are going to be presenting the first wireless battery management system concept car. You will hear the best benefits that you can see in a concept car. Now, afterwards, we will have a question and answer session where you'll have the opportunity to ask the panel any question you like. We have some adorable ladies with microphones. Can you just wave your hand? Yeah, we've got one here. If you have a question, just put your hand up and they'll come to you. Just put the microphone like if you're singing in the shower and they can hear you all then. Okay? So enjoy the champagne, the soft drinks, and I'll pass you to David Qualls, our Vice President. Thank you.
Jackie. All right, everyone, thank you for coming. And as Jackie said, I'm Dave Quarles. So I'm Linear's Vice President of International Sales. And I'm kind of fighting a cold right now, and the cold's winning. So the beer is not a good idea, Jackie, but we'll go from there. So wireless communication in the BMS. So this isn't exactly a new concept. We at Linear have actually been talking and kicking this around for a while. But that was actually the problem. We've just been talking about it. We didn't take an action. So I was with Mr. Daniel Quinger here at the Hanover Messe Fair in Hanover, Germany, which is a big industrial IoT fair. And we were there last April, and I think we have an attraction to each other because we both have the initials DQ, which is pretty rare. But Daniel and I were brainstorming, and I asked Daniel, do you think you could build, with the support of Linear, kind of a desktop prototype to prove this wireless BMS concept? And Daniel said, if you want to prove it, you've got to actually put it into a car. So after a few months of trying to work out the details, we had a one-page contract written by businessmen, not by lawyers. We had a handshake, and next thing we know, the wireless concept was born. And so here's the car here. So I have to synchronize these two things. But here's the car here now, and it works. It's been driven. It was driven here into the show. It's been driven on roads in Germany, so it's not a kind of wishy-washy prototype. It's a real working car, and it's been licensed in Germany. You can see the license plates on the car also. So what's so great about wireless BMS? What are the big benefits? What could it bring to the consumer? And before I start, I wanted to do some basics on what does BMS mean, and what are some BMS basics. So to start with, BMS means Battery Management System. Okay, so what does that mean? So you can see here the battery pack, and then inside the battery pack, there's also some electronics. So the electronics typically are measuring voltage, current, and temperature, and reporting that information through a wire, which is typically CAN bus, which is a popular standard in automotive. And the reason you do that is you understand your range, how much range you have left in your car. So that's kind of a real simple tutorial of how a BMS system works. So as far as the voltage sensing, Linear's had a leadership position in this for 8 or 9 years now. And the reason is because we have the most accurate voltage sensing, we understand safety, which is very important, and we have a lot of experience. We're on our 4th generation now of our BMS IC. So the 6811 voltage sensing chip is also inside this BMW i3. And these things have led us to become a worldwide market share leader in voltage sensing. All right, so the goals of a wired BMS system are to be safe, smart, green, and cheap. And so with the Smart Mesh wireless BMS concept, we took the wired system out and we replace it with Linear's smart mesh wireless technology. And we think by doing this that we could make now a system that will be safer, smarter, greener, and cheaper than a traditional wired BMS system. So let me touch on those 4 benefit points. The first being safer. So the number one failure mode in a BMS system today is the connectors and the wires. So either the connector breaks and the wire breaks. If that happens, your system's not going to work and the car is going to break down. Or even worse, something bad could happen. So with smart mesh technology, it provides redundant paths. So wirelessly, smart mesh will communicate with the micro, and if for some reason the path is broken, then you've got a redundant path to get the information to the microcontroller. You also have frequency redundancy. So the combination of frequency redundancy through channel hopping and redundant paths provides you 5 nines of reliability of getting the volt information from the battery module. The other benefit that makes it safer is there's no chance to introduce a low-cost counterfeit module into the system. So the smart mesh is actually like a private network, and only things that are authenticated can actually join the network. So this makes the possibility to keep any low-cost counterfeit modules out of the system. All right, the next benefit is smarter. Is the system smarter? So the first thing with a wired system, you only know if it's working or not working. And with smart mesh, you actually get network status. So you actually know, is the system working really well, kind of well, or so. So the advantage of that is if for some reason you saw a degradation in the network robustness, you could actually monitor that, and if it continued to degrade, you could send information to the user that they need to get their car serviced. The next smart feature is that it's really easy to add more sensors into the network and that do different things. So in this case, we showed adding a current sensor as well. I might change to that. 1 second, please.
This is not smart mesh, I think.
Okay, can you hear me now?
Yep.
All right, that's better. So more sensors can be easily added to the system. So here we're adding current as well as temperature. So by doing this, we can take advantage now of smart mesh's time syncing ability, because the better you can time sync, the better you can understand the state of charge, which relates to better range, and the better you can understand the state of health, which gives you a better understanding of the life of the battery. All right, the next strong benefit of smart mesh and the wireless BMS is greener. So in a typical car like this, a small BMW, you can save about 30 feet of wire and about 1 pound of connectors and high voltage transformers. And so for a typical car, that's good. Every pound is a pound. But if you look over a series production one year of 50,000 cars, that's about 300 miles and 50,000 pounds of material that's saved and didn't have to be used. So that's good for the environment. Finally, cheaper. So, typically when you have a revolutionary thing like this, the punchline is, oh, by the way, it costs a little bit more. We actually think this is going to be a huge cost benefit to the car makers going forward. And so we think that this new smart mesh technology will give a lower total BMS cost. So today we think that the bill of material cost between a CAN system and a smart mesh system is roughly the same. But today you'll get the benefit of reduced assembly costs. Tomorrow we get to take advantage of Moore's Law, where we go to smaller and smaller frequency nodes. And when we do that with the next generation of smart mesh products, we'll be able to have a substantially lower bill of material cost too. So that's it, our wireless BMS concept. We've proven it works, we've proved it safe, we've proved it secure, and we're developing a demo system that will be available in the first half of this year. So I'll turn it over to Daniel.
Yeah, thanks a lot, David. So I tell you a little bit about our company and what we have done in this project. So LimeSmart was founded 8 years ago with the idea to offer testing services. Very soon our customers wanted us to not only test their batteries, but want to build prototypes for their prototype vehicles or electric airplanes. And from very early on, we figured out that BMS is a key issue, and we bought the BMS from different vendors, and to be honest, they were a pain in the butt, really. We always had problems. They delayed the project. So more than 6 years ago, we decided to do our own BMS system. You can see here on the booth the fourth or fifth generation of our BMS system. So the idea we came up is these black box BMS system, which delay the project and slow down the project. We want to do it differently. We want to do something like Linux for batteries. So we said from the beginning on that our software stack will be open, and we provide the whole source code to our customers. So they can decide either if we change the software, or they can themselves be trained on the software and can make changes to the software by themselves. So this also means that our customers are not dependent on us, and we will always keep hard work and have to convince them that we are the right partners, because with an open system they could say every day goodbye, and we do it on our own if they are not satisfied with what we can offer. So I elaborate a little bit on the advantages of an open system. So first, as I already mentioned, is reduce development time, and the second is that you can reuse code, and for me much more important is with the systems today, where basically the battery management system, 99% of them do all the same stuff. They calculate the SOC, they have to manage the balancing, they do the CAN bus communication with the car, and today with proprietary systems you're wasting a lot of engineering talent, because like 100 people are doing the same stuff, and instead of working together and really focus on the differentiator towards the customer, not like redoing stuff which has already been done, I think this could speed up the advent of electric vehicles. And also we can use this open battery management system in different applications. So we have used it obviously in cars. One of our partners, Chrysler, they're using the open system in their stationary storage, and also Airbus is one of our customers with their electric flight. They love our open system because, simple example, in a car, off is a safe state because you can drive on the right side of the road. In an airplane, obviously off is not a safe state. So they have to come up with a totally new safety architecture for an electric airplane, and with our system they just have to change the state machine and can keep the rest of the software, and don't have to start from zero all over and do a purpose BMS for airplanes. So that's why Airbus likes our system to use it in their prototype electric airplanes. So I say a little bit how we did it here in the project. We used the original space of the i3 where the battery normally goes in. We took the original BMW battery out and put a new battery in. With our laser welding partner Chrysler, we assembled 4,618 650 cells, so the same cells as Tesla is using in their Model S and X. Laser welded them together in 10 modules. So we have a 100S 46P configuration in our system, and basically all the modules can talk wirelessly to the master. So each of the modules has a module controller, and they talk without any wires to the master controller. One of the big advantages is, as David already said, we can utilize the high accuracy of the voltage measurement from the LTC 6811, and we can also utilize the high accuracy of our current sensor. And what is forgotten by most of the battery developers, if you want to make precise SOC and SOH calculation, as it's all been done by state space models, so time discrete state space models, you have to have accurate timing. And as the dust network is a time synchronized network, we can timestamp the measurement data and make it much easier for the battery model and the Kalman filters or whatever to figure out what is the real SOC, or if I have any errors, where do they come from? Do I have to change the value of the capacity of the pack or the resistance to make better prediction? So actually with the time synchronization, we can use more of the available capacity of the battery. So this is also a way to make it greener, because we can utilize the existing capacity of the battery better, because we are able to model the battery more precise than it's normally possible. Yeah. I have to thank David for making this possible for us. We are like a small company with 60 people. Working with Linear now for 6 years is really a pleasure. I have not ever before worked together with a company which is so open, so quick in making decisions. So a big thanks goes out to Linear, and a big thanks goes out to my employees who made this possible. So Paul, he's with me, he's our software guy. These are the guys who make this possible in 4 months, and also the managers who are quick on making decisions. So big thanks, David. Okay, so
hello? Right, so now we're going to open up the question and answer session. So if you have a question, please raise your hand so our beautiful helpers can come to you with the microphone. So let's start over there.
Hey guys, I was just curious, Smart Mesh IP, is this something new, a new technology?
Great question. Our Smart Mesh products have been in the field now for about 12 years. There's more than 50,000 systems deployed, but the primary area of application had been in industrial Internet of Things applications. Everything from monitoring oil refineries, to steel mills, to coal mines, to data centers, a wide variety of applications, but this is the first application of the technology in a car.
If it's such a good idea, and you're kind of doing a good job at convincing us that it is, how come OEMs haven't already done this and incorporated it into their vehicles, their own batteries and battery management systems? You know, how come you come up with it and they haven't?
I just heard that should be nice. As I have been working before I founded the company for OEM, I know that there's a different culture in the car industry in comparison to the IT or the silicon industry. As you drive around with these things with almost 200 kilometers per hour, at least in Germany, you have to put a certain effort in making them really reliable. And as this is like really cutting edge technology we are using, the laser welding, the Smart Mesh IP network, it takes time from proving something that is possible, doing it and bringing it into mass production. And I would guess if we can convince the OEMs that the benefits outweigh the potential risk of such a system, then they will migrate towards this. But as the car industry goes, with some exceptions from California, they tend to be very reluctant on changing the system. So don't touch a running system is like in the DNA of the car industry, and I think this is, it's not really a technology reason, but more a cultural reason, I would say.
Okay, thank you.
Further questions? Can you raise your hand? Over here, the gentleman.
Thank you, great technologies. My question is, you mentioned about the microcontroller unit. Is it your own proprietary microcontroller unit, or you are using some off-the-shelf chipsets?
So in the dust, I think we have an ARM Cortex M3 included. On the master side, we still use a PIC32. This is some heritage from how we started. We will migrate this year to a dual core lockstep, probably ARM or STM. Let's see.
Further questions? Can you raise your hand, please? I'm very small. Oh, there we go.
How quickly do you think you can scale up this project?
You mean how fast when we can go into mass production? I think we should take a couple of months of testing to have enough data to show the customers that it's really reliable. But in theory, the PCBs are ready. We call our PCB manufacturer in 8 weeks, have as many as the customer possibly wants.
Further questions? Can you raise your hand? Oh, there's another one here.
Sorry, am I allowed to have two?
Yeah, you can.
Okay. I hope I was listening okay earlier on when you were saying about the kind of cost-benefit analysis, but I'm just trying to sort of think, you know, what is that? Can you be a little bit more detailed on how that is? I mean, if it costs $100 but only saves $100, then it wasn't worth doing. So how does that kind of work?
I think the true cost benefits won't come from the material saving itself. It is a part of the equation. The bigger is when you look at the whole product lifespan, how the battery is moving through production. Today, basically, if you have the modules which are assembled into a battery system, you either go there and connect a cable and run some diagnostic over CAN, which is quite intense workload. With the wireless, you can, in production, flash the modules with a diagnostic software and have a much more reliable production with less faults in production. I think their saving comes from, and also you can think of at the end of the life when the battery is recycled or goes into a second life scenario, for example stationary storage. It makes it much more efficient, because you can think of taking 10 cars and maybe the third module from the first car fits perfectly together with the sixth module of the seventh car or what. And today you have to send a guy plugging in a CAN bus diagnostic software and analyze it and read out the data. Here you can basically over the air put software on the battery modules and tell them, hey, run an algorithm which finds out which module fits to the best. And you have to think the savings comes from the process and making the whole system more reliable and having less service cost in the end, which you can transfer to the consumer.
Okay, thank you.
Thank you. Further questions? Any further questions for our expert panel? No, I've got one question. Oh, is there any over there? Yeah, just a moment.
You mentioned that it took only 4 months to get it done. How was it possible? I mean, traditional OEMs, they needed at least 1 or 2 years to get a project like this done.
So when we talk about development, prototyping is something different than making a product which is produced 100,000 of times over a couple of years. Surely, when I think of my time when I was working for an OEM, there was one project going on in the company where we also prototyped an electric car, and we did it in 11 months, and this was the fastest prototype development project within this company ever. So as a startup, and having, as I said, managers who make quick decisions and not go back and forth making decisions for ages, and the developers sit there and wait for the decision, and having developers which are capable of implementing stuff really fast, and also that companies work together very closely and connect the engineers and don't try to figure out who's to blame for anything, but to solve the problems. Not find the one who is responsible for the problem, but focus on solving the problem. This is the key aspect of the whole thing.
Also, the Smart Mesh IP wireless networking system, all of the wireless networking software is provided, pre-compiled, fully tested, over temperature, over extreme conditions. And so customers need only write to a very well-documented, well-tested API to get a system up and running.
Yeah, thank you.
Any further questions? Yes, of course.
Just curious, is there any adopters of these technologies? Can you name 2 key players, key manufacturers there?
So what I can say with our laser welding partner Chrysler, who will offer by mid of this year a really revolutionary stationary storage system. In the moment it is wire bound, but we are thinking of the next generation with them on implementing this wireless BMS first in stationary storage, because there the requirements are much lower than in the car industry, and there if we roll out a big number of these systems in the field and have them working fine, I think we have an easier job as a group to convince the car guys also utilizing this technology.
On the wireless side, of course, in the non-automotive world, we have many customers, including Emerson, ABB, Siemens, startup companies such as Streetline Networks using it for parking management, Vigilant using it for data center network management, and here on our booth, in fact, we have several partner companies who are using the technology to create solutions.
Further questions, gentlemen?
I just have one question. What kind of yield rates are you looking at in manufacturing from prototypes and then on to mass production? Manufacturing yield rates, you know, I mean, I believe you said you're in 50,000 units over the years, but as you guys roll out your software into hardwares, what kind of yield rates?
It's not 50,000 units, it's 50,000 networks.
Sorry.
These are typical semiconductor. I mean, this is fundamentally, the core of this product is basically semiconductors, so we're looking at the same kinds of extraordinary yield rates that we're typically looking at for semiconductors. All of these products are in production. All of the products being used, all of the semiconductors being used in this implementation are already at production level quantities.
Thank you.
So when we talk about the stationary storage, so I think over the first couple of years we are talking about millions of ICs which will go into the stationary system, because in an average stationary system you would have at least 9 smart mesh IP dust modules and at least 8 measurement ICs. So you always can take the numbers of batteries and multiply it roughly by 10, and then you know how many chips will be out there. So I think today we are talking about sales of 1 million electric vehicles globally each year, and this is almost doubling each year. So we are talking about a market of tens of millions ICs, rapidly growing.
Any further questions? Just raise your hand. No further questions? Right, I think we should thank the panel. I think they've done pretty good. Now for you, those of you who are press, we've got a press pack, so if you're interested, please come to me and I can give you one. And for those of you who want to keep a memorabilia of the car, we've got our miniature i3 wireless battery management concept car. So if you're interested in one, just come and see me too. Right, thank you very much. You've participated in the launch of the first battery management system, wireless battery management system car in an i3 BMW car. Thank you. You've seen it here first at Linear Technology. Thank you.
Well done, Jack.